Log graphs are the inverses of the exponential graphs, and so the way that you could graph this is by plotting some points. And for example, if you looked at 1, b to the 0 power equals 1. So you would see that 1, 0 would be one of the points. And you could do the same thing here. So this is if your b is between 0 and 1, it's going to look like this. And notice on both of these that your x's are going to be greater than 0. You can't take that b to any exponent cannot equal a negative number. So that's why it's always going to be on the right side, or where x's are going to be positive. And you have some of the characteristics down below. If you looked at graphing this f of x equals log base 6 of x, and if you wanted to graph, for example, 6 to the x equals y, you're going to see that that's an exponential, so it's going to look like this. And when you graph the log, this is going to reflect about the y equals x line, because you're changing the x and the y around. So if you were to get a table with this and switch the two, you would end up with these points. So that's another characteristic of inverse functions, is it reflects over the y equals x line. I want to go ahead and graph this one and talk about some of the characteristics. First of all, you can rewrite this as 3 to the y equals x. What I like to do on these graphs is choose my y's to get my x's. So for example, if y was 1, I would know that x is going to be equal to 3. Y is 0, I know x is equal to 1. And where y is 2, x is equal to 9. And negative 1 is another one that could work out quite easily. So I'm choosing easy numbers here on the y to get my x's in reverse. Okay, so let's go ahead and graph this. Let's see, 1, 0, 3, 1, 9, 2, and this last one, negative 1/3, negative 1. And that's a mistake there. That should be a positive 1/3. So 3 to the negative 1 power equals 1/3. And so this is going to be here at 1/3, and I'm at negative 1. So this graph, as you can see, is going to come up like this and then go straight across, not touching the y-axis. Now, if you had a negative sign in front of there, then what would happen is you would reflect it about the x-axis. So that would mean that it's going to come up like this and go down. That would be a negative in front. And then if you had a subtracting 2 off the x, that means it's going to go to the right 2 units. So you could translate this one to get to the second one. Now, very quickly talking about the domain range. The domain are going to be all real numbers greater than 0 to infinity. The range is going to be all real numbers. Intercepts only 1, 0. Asymptote is x equals 0. And that's it, because this is going to go to infinity, but it's going to hit all of them. And end behavior is as x goes to, right end behavior as x goes to infinity, your y is going to go to infinity, And as x goes to 0 from the right side, let me write that down, left end behavior is going to be as the limit as x goes to 0 from the right side, that's a plus, of f of x, your f of x is going to go to negative infinity because it's going to go down as it gets closer to 0. Notice the notation, very important on notation. Increasing or decreasing, it is going to be positive slope on all these, so it's going to be increasing, and the interval is going to be going from 0 to infinity. So there's some characteristics of the logs. Notice again how I did this. I changed the form to an exponential, and then I started with my y's and went back and filled in my x's.